everyone, welcome to this channel. So let's start with why linked list is going to be the very first video of this course. So yeah, let's get started with it. So first of all, what we need to understand is why linked list, not what is linked list. That is not going to be our first concern. Our first concern is why are we starting linked list? Why do we need linked list? So yeah, let's get started with that. So first of all, as I said, as I have already mentioned in the introduction video to the course, that you should know object-oriented programming and arrays before learning about linked list data structure. So I hope that you know that much. Okay, now I'm going to start with why linked list. Okay, so what I've done here is that I have drawn an array. This is an array, and this is something that we'll see. So let me just take you a little bit deep into the arrays. Let us just revise a little bit about the array data structure before we begin to study about the linked list data structure. So let's dive deep into array data structure. It's not very deep. It's obviously some things that you will already know, but yeah, let's start it. So if I have made this integer array, now consider this as an integer array. So I'll in fact write it here that this is basically an integer array. Okay, so this is an integer array. Then you can tell me what is the size of this box and what is the size of this block, this block, this block. What is the size of each block? See, we're talking about Java. So in Java, I've already told in the course introduction that this course is going to be in Java. So yeah, it is going to be 4 bytes, right? So in Java, integer is of size 4 bytes, right? So each and every block, this block, this block, this block, each and every block is going to be of size 4 bytes. I hope that is clear. Now, what we are going to do is, let us say that the starting address of the 0th index block, that is the block that's having the 0th index, let me say that the starting index, that is the starting address, see, if I say that let's say I'm talking about two different situations here. What two different situations? One situation is this that I've drawn here. We'll talk about that later. Now consider the very first situation that I'm talking about here right now. Now please concentrate. This is an array of size 5. There are these indices 0 to 4, right? Now what I'm saying is that this is one block and this block is of 4 bytes. This is of 4 bytes. Now, I say that let us consider a memory where each memory address corresponds to 1 byte. That is, if I write this as 4K, that is 4000. So let's say 4000 is a memory address. It corresponds to 1 byte. Then 4001 will correspond to another 1 byte. 4002 is another memory address that corresponds to another 1 byte. So if we keep doing that, we can say that if this is starting from 4000, then it is actually, if this is, the starting is 4000, then it is actually from 4K to 4K03 because the size is 4 bytes, right? So if the size is 4 bytes, then 4K, 4K01, 4K02, and 4K03 because the size of an integer is 4 bytes. So these 4 bytes, these 4 memory locations, these 4 bytes will be occupied by the integer that will be stored in the 0th index block of this array. I hope that I've made this clear, right? So this address, if you remember, the address of the starting address of the very first block, the 0th index block of the array is known as base address. So this is the base address of this array. So this is the base address of this array. So I've written here base address. Okay. So if this is 4K, then these 4 bytes, that is 4K to actually 4K to 4K03. I'm writing 03 here. So this will be occupied by this block only. I hope that I made that much clear. So what will be the address, the starting address of this block, the block with index 1? Now you can see that the starting address will be 4K04. Why is that? If you remember that array is basically a contiguous collection of same data type. Now we're talking about Java. We're not talking about JavaScript because in JavaScript it is not necessarily the same data type, right? So like I assume that we are all coming from Java. I'm teaching in Java. So yeah, let's talk about Java only here. So if this is 4K, then this address is going to be 4K04. Why? Because 4K to 4K03 were occupied by this block. Now 4K04 onwards will be occupied by this block. I hope that is clear. So basically it will be 4K04, then it will be 4K05 and 4K06 and 4K07. So these four blocks will be occupied by uh, this. So I've written here in this way. So let me write it in a similar fashion. So if we talk about the block with index 2, it will start from 4K08. Then if it is starting from 4K08, then 4K09 and then 4K10 and 4K11 will be occupied by this block only. Then if we are talking about this block, it will start from 4K12, then 4K13, 4K14 and 4K15 in fact will be occupied by this block only. Then if I talk about this block, it will start from 4K16 and then 4K, let's say 17, 4K18 and 4K19 will be occupied by this block only. So this is a basic memory diagram of array that if this address is 4K, that is a base address is 4K. So first 4 bytes will be occupied by this block. Then contiguously, in continuation, the next 4 bytes will be occupied by this block. Next 4 bytes will be occupied by this block. Next 4 bytes will be occupied by this block. Next 4 byte will be occupied by this block. Now you can contain any data in it. Let us say the data. Let's put some data in it. So let's say the data is 9, then 8, then 6, then 3, and then 4. Let's say this is the data. So yeah, I've put some random data into it. But yeah, you understand what I'm trying to say, that the memory was contiguous. So the important point here is contiguous memory, right? So contiguous memory. If you remember, this is what arrays used to be. The memory used to be contiguous. Now, let's move to this diagram. What is this diagram depicting? So let me show you and let me explain to you what this diagram is going to. And now you have to look at this very carefully because it's very important and it is actually the why of the linked list. I have not included the word uh, right now, but it has been included in the title. I've not included it in the video. Yeah. So let's see. So this is, we can see that there are 4 columns and 6 rows, I guess. Yeah, so there are 6 rows. So a 6 cross 4 block, a 6 cross 4 matrix, you can say. It's actually the computer memory that I've drawn. Okay, so this is 1, 2, 3, 4, 5, 6, and you can see that 1, 2, 3, 4, obviously. Okay, so that's a 6 cross 4 memory that I have drawn, right? It's a computer memory. Now, one very important point about this memory that I am writing here, it's a very, very important point in this aspect. Now, it's just assumption, I'm just taking this example in order to explain you the concept. So here, I'll say that one block equals 4 bytes. Now, this is just an example. This is just an example to explain you a concept. It's not that in computer memories, one block equals 4 bytes. It's not that. I'm just explaining it to you with the help of this example. So if one blocks is equal to 4 bytes, now let us understand, will we be able to create this array inside this memory? Let's see. So what do we need? We need 5 empty blocks. That's wrong. We don't need 5 empty blocks. We don't need just 5 empty blocks. We need 5 empty blocks in continuation. That's what we need. Okay. So here, if I'll see, here I've got 3 empty blocks. Here I've got only 2. So if I start from here, I've got 4. Here I have got 5 empty blocks. That's it. So I can construct this array inside this memory. Now you should understand why I'm saying that one block is equal to 4 bytes, because each block is representing the block of an array, which is 4 bytes, because integer is of 4 bytes, right? So yeah, that's how it is. So I will be able to, create this array if this is my memory. What these dots are depicting, why have I not considered these dots? Because these dots depict that the memory is already occupied here. If this is a dot, this means that the memory is already occupied. That's why I said that only 3 blocks are available, because this is not available to us. Here only 2 were available. This was not available to us. Here, these 4 blocks were available, this block and these 3 blocks, but this was already occupied. Here, these 4 and these 2 are available to us. That's it. So 6 continuous blocks are available to us at max in this memory, and we just need 5 continuous blocks. So we will be able to make this array. Now, what if I want to make an array of size 6? I will be able to do that also because there are maximum 6 continuous blocks available to us. That's great. What if I want to make an array of size 10? Now I won't be able to make an array of size 10 because I don't have continuously basically 10 blocks available with me. Now you might be thinking that why is that so? This is the continuous blocks available to me. No, no, no. These blocks, you have to assume that they are in continuation in this way. At this row, after this row, then after that 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 this row. So you have to assume their continuation in this way. So if you're assuming their continuation in this way, then you can clearly say that no, we don't have 10 blocks available in continuation because here we have only 3, here we have only 2, here we have 4, here we have 6, but like 6, that's it. And here we have 3 and 2. So we don't have 10 blocks available in continuation. So we'll not be able to create an array of size 10. If you see, this is basically 4 cross 6 cross 4, 6 4 is a 32. That is, it is a 32 blocks, right? It's 32 blocks and only 1 2 3 4 5, that is 5 blocks are occupied. So 27 blocks are empty. 27 blocks are empty. And even if 27 blocks are empty, even after 27 blocks being empty, we will not be able to create an array of size 10 just because we require the memory to be in continuation. That is called fragmentation. What is fragmentation? Now, this is there in the video title. I've mentioned the word fragmentation. So, what is fragmentation? Fragmentation is basically the phenomena in which this memory, this computer memory, the concept, the process, the phenomena in which this computer memory is being divided into fragments. There is a lot of free memory available to us. This memory is free, this memory is free, this is free, this is free, this is free. If you see, this is all the free memory available to us, highlighted in green. Even if we have a lot of free memory available to us, we will not be able to use that memory because it has been divided into fragments and we need continuously larger memory. This is the concept of fragmentation. So because of fragmentation, there arises a problem that we are not able to create an array. So I have written the word fragmentation here. Okay. So fragmentation causes problem for us because of which we are not able to use this memory. So now if you get an idea that arrays create a little bit problem because they require contiguous memory. Now I have shown this for actually a very small array and a very small memory. You have to imagine this for a large memory, large size array. Obviously, this is not a real life situation that I have shown you. And I can't show you a real life situation because I can't draw such big array and such big memory. But yeah, you have to imagine it for huge array and a huge memory, obviously, like 4 GB, 8 GB RAM available in your computers. So this is the concept of fragmentation, and this is why we need linked list. In order to get rid of this fragmentation problem, we need linked list. Now, how does linked list get rid of this fragmentation problem? Like something that is coming to my mind currently is that probably, obviously, they will not have contiguous memory. The linked list will not have contiguous memory. Because if they have contiguous memory, then still the fragmentation problem will remain. This problem of fragmentation is arising because the memory is contiguous in case of arrays. So just remove the contiguous memory. But if the memory is not contiguous, that is, it is like that this block is occupied, then this block is occupied, then this block is occupied. Now this is already occupied. No worries. I'll keep it here. So if the situation is like that, that our data is going into whatever block it finds free, then how will we able to keep the track that where is our data exactly? Here, keeping track is very simple because we just have kept the base address with us and we know the size of the array. So we will be able to calculate address of each and every block. This is something that we won't be able to do in linked list. So how are we going to keep the track that where is our data in the memory? That is what is interesting about linked list data structure. And that is what we'll be studying in the next video. What of the linked list? That is, what is linked list? That is going to be our next video. Till then, if you like this video, then then please like this video, give it a thumbs up, and share this video with your friends so that they could learn about why you require linked list and what is fragmentation. Also, please consider subscribing to the channel and hit the bell icon. I'll see you guys in the next one. Till then, have a good day, take care, and